now that I've given you the teaser about functional programming and why it's a big win, I will very quickly go through the overview of object-oriented concepts and features in Java, just to give you the background of all this stuff. And we'll talk about sort of the core abstractions. You can read this article by the inventor of C++, Bjorn Strustrup, talking about what is object-oriented programming. And even though that article is like 30 years old at this point or so, it's still relevant. What he describes there still applies. So Java, when it came out in 1995. It was based on some earlier work that was done at Sun Microsystems called Oak a few years before. And it was originally just an object-oriented programming language. And what that means is it supports object-oriented concepts and features. Those features are data and control abstraction, so things like classes and packages and methods and if statements and while loops and switch statements, all that kind of stuff. Hopefully you all know from earlier classes. And this allows you to define these APIs that shield developers and users, which are users being programmers, from low-level implementation details. So you don't have to know how like a stack is implemented to use the API, the application programming interface for the stack. And that's sort of CS 101, CS 201 kinds of things. Another feature it had was the concept of inheritance, which we sort of cover in 101, but is a crucial part of Java and object-oriented design and programming. What inheritance does is that it enables systematic reuse of existing methods and fields that come from so-called superclasses that are inherited or derived by subclasses. And then the third key feature is polymorphism, which is a fancy term that means sort of many forms or many shapes. And this is done in languages like Java and C++ and C# and so on, and Python, by something called virtual methods that allows the runtime system to dynamically dispatch the appropriate method in a hierarchy that is inherited based on the runtime type of the object that invokes the method. So this is a core part of object-oriented programming. I'll show you some examples. You may or may not realize that you already know all this stuff. This is just fancy ways of explaining it more abstractly than we sometimes think about in terms of Java with its final methods versus its virtual methods and so on. When you write an object-oriented program in Java, it's organized in terms of structural elements. And the most obvious ones are the classes and the interfaces and the packages. And again, I suspect you're very familiar. Hopefully, you're very familiar with what a class is. You're hopefully somewhat familiar with an interface. An interface is just kind of a lightweight version of a class. And a package is just a way to group a bunch of classes and interfaces together in some logical grouping of some kind. What's an object? An object is an instance of a class that can perform certain operations, and it can interact with other objects. So when I think about a class, I think about a cookie cutter. And when I think about the object, I think about a cookie, right? So the cookie is the realization of the cookie cutter. Obviously, objects live someplace. Where do they live? They live in memory. That should be pretty straightforward. And here's a simple example that we'll talk about throughout this discussion of a simple set, which has some fields, as we'll see, and a bunch of methods. And here's an example of this. Here's our simple set class, which extends some superclass called abstract set. And you can see here it's got a bunch of methods and a bunch of fields. If you take a step back from this, you can think of a class as basically containing state, which are the fields. These would be things like the element data, the size, the end, and so on. And you can also imagine it containing these fields in ways that can be hidden or exposed with various degrees of granularity. So in Java, hopefully you realize this by now, fields should almost always be hidden by being defined as private access control specifiers. Methods, in contrast, would typically be made public or private. You could also make fields, methods are usually public, helper methods are private, and you might use protected as a way to be able to allow subclasses to do special things that you wouldn't just let any random client be able to do. The other kind of capability you have, of course, are behaviors, which are represented by methods. Again, with our SimpleSet, you could have a bunch of methods. And then here's some examples of these, where you could have some public methods like size, which just is an accessor that returns the M size. You could have isEmpty that does some comparison. And you can also have methods that are private, which cannot be accessed by anybody except the class implementation. If you're doing object-oriented design correctly, your objects and your classes should correspond somehow to, quote, real-world entities. The real world, of course, depends on the domain that you're in. So if you're doing some kind of an accounting software, you might have an account class with an account object, and that, of course, would have various methods and fields. You might have, the balance and the overdraft protection as fields, and you might have methods to deposit, withdraw, and check as the behaviors, as the methods. Again, not too much surprising there. Hopefully this is just review. Non-object-oriented languages organize applications in terms of functional elements or actions. And there are lots of examples of these historically: Fortran, Ada, C, and ideally you know something about these languages, at least historically. So actions and logic are the way things work. And you typically design programs using stepwise refinement with algorithmic decomposition. That's the way you do those kinds of things. Object-oriented programs in C++ or C# or Java also, of course, contain actions and have logic, naturally. The actions are typically defined in terms of these methods, but the methods always exist in the context of a class. And that's intentional. It's intended to be able to emphasize cohesion and loose coupling between the classes and the objects. The main difference in an object-oriented design and an object-oriented language is the way in which we break the program up into chunks is based around these classes and interfaces and objects instead of these functions and actions. It's not that we don't have functions and actions. That's not the point of the design. Now, the funny part about all this stuff is we've now come full circle. So now that Java 8 and beyond has come into existence, they all of a sudden add all this functional programming stuff back into Java. So after learning for a couple decades that actions and functions are evil, all of a sudden we add them wholesale into Java, and now we love them and talk about them. And at first that may seem like a conflict, but in fact it's actually not. The way to think about this, and we'll talk about it later, is that the object-oriented features like classes, inheritance, dynamic binding are really there about help you structure your application's architecture in terms of reusable entities and elements that are loosely coupled and highly cohesive within a given class or interface. And then when you need to do computations within a method in a class, then the functional programming paradigm comes in really nicely to help you implement those computations very concisely by focusing on the what, not the how. So these things actually live together quite well. And it's actually not a problem. There are many, many, many object-oriented languages. There are many, many functional programming languages, too. These are some of the most common ones. Today, you probably know some of this stuff. If you want to amuse yourself and decide where you want your career to go, every so often you should take a look at the TOB index, which will tell you what's the hottest programming language based on some criteria. And for the last many years, Java has been the hottest programming language, but there's a bit of churn underneath that. So some rise, some fall. C is usually also very popular. Python, C++, Swift, Go, those things tend to kind of jockey for the top 10. Once you know Java, it's easier to learn some other language. Object-oriented language is very easy. And once you know another object-oriented language, it's fairly easy to learn Java. If you know Java, then some of what I just said is probably very boring, but be aware we're not going to spend much time on this. We're almost done with our overview of the OO parts of Java. You can move through this very quickly, but make sure you understand it because everything else in the course is based on it. So you need to know what a for loop is, you need to know what a class is, you need to know what an interface is, even if you're not going to be required to focus on that in detail. If you need help, our MOOC, Java for Android, could be a good place. If you enjoyed Jerry Roth and Julie Johnson's lectures for 101, they also appear in video form, and they will talk to you very close and personal, so you can learn from that. So that's the end of this discussion for today.